A large motor turning on and disrupting a DSL internet connection suggests a few potential issues that could be causing the problem. Firstly, electrical interference from the large motor can create noise that interferes with the DSL signal. This noise can be conducted through the power lines or the telephone lines, disrupting the data transmission. Secondly, voltage fluctuations caused by the motor's startup and operation can affect the stability of the DSL connection. Large motors often draw significant current when starting, leading to voltage dips that can impact sensitive electronic equipment like DSL modems. Thirdly, ground noise might be the culprit, especially if the motor's ground system isn't properly bonded. This can allow noise to be induced into the telephone line, disrupting the DSL signal. To troubleshoot this problem, consider the following steps. 1. Ensure that a DSL filter is installed on every telephone line in the building, even those not directly connected to the DSL modem. DSL filters block high-frequency noise from entering telephone equipment, which can interfere with the DSL signal. 2. Verify that the power supply to the DSL modem is stable and free of voltage fluctuations. Use a multimeter to check the voltage at the outlet power in the DSL modem to ensure it remains within acceptable limits during motor operation. 3. Isolate the motor by turning off all other electrical equipment in the building and see if the DSL connection remains stable while the motor is running. This helps determine if the motor is the sole source of interference. 4. Check the grounding of the motor to ensure it's properly connected and has a good connection to the building's grounding system. A poor ground connection can allow noise to propagate more easily. 5. Install a surge protector on the power line to the DSL modem to protect it from voltage spikes. Surge protectors can help mitigate the impact of voltage fluctuations. 6. Contact the DSL provider if the problem persists, as they may have additional troubleshooting steps or can send a technician to investigate. Additional tips to consider include the following. 1. Place the DSL modem as far away from the motor as possible to minimize the potential for direct interference. 2. Use shielded cables for the DSL connection to help reduce the amount of noise that can be picked up. 3. Ground the DSL modem to the building's grounding system to provide a low impedance path for noise to ground. 4. Connect the UPS to a dedicated power outlet that isn't shared with the motor to avoid potential voltage dips. Checking the motor's installation according to the 2014 National Electrical Code, specifically Article 430 covering motors, motor circuits, and controllers. Ensure the motor's overcurrent protection is correctly sized to prevent nuisance tripping and potential voltage sags. Look at section 430.52 for proper sizing of motor overcurrent protection. Verify that the motor's conductors are sized according to section 430.22, ensuring they can handle the motor's full load current plus any applicable safety factors. The grounding and bonding requirements in Article 250, especially sections 250.118 and 250.130, are crucial for minimizing noise and ensuring safety. Make sure the motor's frame is properly grounded to the building's grounding electrode system. The DSL modem and related network equipment should also adhere to grounding practices outlined in Article 800 for communication circuits. Ensure proper separation between power and communication cables. Section 725.136d provides guidance on separating power and data cables to reduce interference. Check the voltage drop in the circuit supplying the motor. Excessive voltage drop can affect the performance of both the motor and other connected equipment, including the DSL modem. Sections 210.19a1 and 215.2a3 provide guidelines for minimizing voltage drop in branch circuits and feeders, respectively. Ensure all electrical connections are tight and free of corrosion. Loose or corroded connections can create resistance, leading to voltage drops and increased noise. Check the motor's power factor. A low power factor can indicate inefficiencies in the motor's operation, potentially contributing to voltage fluctuations. Power factor correction capacitors can improve the power factor and reduce voltage sags. This can be particularly important for larger motors. If using variable frequency drives, or VFDs to control the motor. Ensure that the VFD is properly installed and configured. VFD can generate significant amounts of electrical noise if not properly shielded and grounded. If the motor is located in an area with sensitive electronic equipment, consider using a line reactor or filter to reduce the amount of noise that is radiated or conducted from the motor. A line reactor can help to smooth out the current waveform and reduce harmonic distortion, while a filter can attenuate high-frequency noise. Inspect the motor's insulation for any signs of damage or deterioration. Insulation breakdown can lead to ground faults and increased noise. Use an insulation resistance tester, megameter, to check the motor's insulation resistance. Replace the motor if the insulation resistance is below acceptable levels. Check the motor's bearings for wear or damage. Worn or damaged bearings can cause the motor to vibrate excessively, which can contribute to noise and interference. Replace the bearings if necessary. Ensure that the motor is properly balanced. An unbalanced motor can vibrate excessively, leading to noise and interference. Balance the motor if necessary. Verify that the motor is properly lubricated. Inadequate lubrication can cause the motor to overheat and generate excessive noise. Lubricate the motor according to the manufacturer's recommendations. Check the motor's cooling system to ensure it's functioning properly. An overheated motor can operate inefficiently and generate excessive noise. Clean the motor's cooling fins or replace the cooling fan if necessary. If the motor is controlled by a magnetic contactor, inspect the contactor's contacts for wear or damage. Worn or damaged contacts can cause voltage drops and increased noise. Replace the contactor if necessary. Check the motor's control wiring for loose or corroded connections. Loose or corroded connections can cause intermittent operation and increased noise. Tighten or replace any loose or corroded connections. If the motor is powered by a generator, ensure that the generator is properly grounded and that the generator's voltage and frequency are stable. Unstable voltage or frequency can cause problems with the motor's operation and can also affect other connected equipment. Check the generator's output voltage and frequency with a multimeter and a frequency meter. Adjust the generator's settings if necessary. If the motor is used in a critical application, consider installing a motor monitoring system. A motor monitoring system can track the motor's performance and detect potential problems before they cause a failure. The system can monitor parameters such as motor current, voltage, temperature, and vibration. Inspect the motor's junction box for proper wiring and connections. Ensure that all wires are properly sized and that all connections are tight. Replace the junction box if it is damaged or corroded. Check the motor's nameplate for important information such as the motor's voltage, current, horsepower, and speed. Use this information to ensure that the motor is being operated within its design parameters. If the motor is located in a hazardous location, ensure that it is properly rated for that location. Hazardous locations require special equipment and wiring to prevent explosions or fires. Refer to Article 500 and following articles for more information on hazardous locations. Consider using a power line conditioner to filter out noise and voltage fluctuations from the power line. A power line conditioner can provide clean, stable power to the motor and other connected equipment. Ensure that all electrical work is performed by qualified personnel and in accordance with the National Electrical Code and local electrical codes. Improperly installed or maintained electrical equipment can be dangerous and can also cause problems with other connected equipment. After making any repairs or modifications to the motor or its electrical system, test the system thoroughly to ensure that it is operating properly. Use a multimeter, an ammeter, and other test equipment to verify that the voltage, current, and other parameters are within acceptable limits. Document all repairs and modifications that are made to the motor or its electrical system. Keep a record of all maintenance activities, including dates, descriptions of work performed, and parts replaced. This information can be helpful for troubleshooting problems in the future. If the problem persists, consult with a qualified electrician or motor repair technician. They can help you to diagnose the problem and recommend the best course of action. In conclusion, addressing DSL interference from a large motor involves a systematic approach. starting with identifying potential sources like electrical noise, voltage fluctuations, and grounding issues. Implementing troubleshooting steps such as using DSL filters, verifying power supply stability, isolating the motor, checking grounding connections, and using surge protectors can help pinpoint the cause. Additional tips like physically separating the DSL modem, using shielded cables, grounding the modem, and dedicating a power outlet for the UPS can further mitigate the problem. Consulting the National Electrical Code, particularly Article 430, ensures proper motor installation and protection. If the issue remains unresolved, seeking assistance from a qualified electrician or the DSL provider is recommended.